got some homework help for you for problem 3 for Algebra Chapter 4.3 homework. And in this one, we've got the case of a person walking. We have d equals 4.7 plus 2.8 times t. So let's go ahead and put that into our calculator. I'll turn it on. I will come up here to y, and we have 4.7 plus 2.8x. Remember that x is the independent variable, and y is the dependent variable. And I will go ahead and hit enter, and then I will say that I want to graph. All right. I'm not sure about that. This is the best sort of a window to have for my graph. So my graph is eventually going to look like the y-intercept, and it's okay if you don't remember this. The y-intercept is 4.7, and my slope is 2.8. So at 1 unit of time, at 1 run of time, I will rise 2.8. When time is equal to 2, I'll be at about, maybe about 9. Okay, so with that quick sketch on my graph, let me go to my window, and let's make x max equal to, let's make that equal to 12. We'll make x minimum 0, we'll keep it that way. And let's make x max 12. We'll make the y minimum, we can keep it at 0. We could probably make it bigger than that if we wanted. And let's do y max at, say, 15. So let's see what kind of that does for our graph. All right, my window is looking a little bit wide here, so I'm going to shorten down my time. So I'll go back to window, and I don't want the x to be as broad as it is. So let's, whoops. We'll keep that at 0, and let's top that out at 6 and see what that does for our graph. That's a little bit better. I'm going to make it a little bit, I'm going to go even, change that from 6 to 4. Let's see what that does. And hit graph. Oh, that's a lot better. Okay? And it looks like the one that I sketched. So let's do some tracing on that. And the question is, at time equals 12, so that's when x is equal to 12. Look at that. My graph keeps going, even though I'm out of my original window. So I was wrong. My window should have been I made my window way smaller than it needed to be. You know, let's fix that. We'll fix that. We will make x max, we'll take it back to 12. We were good where we were. And we'll put x min back to 0. Let's see what that does to our graph. Okay, now let's trace. So when x is equal to 12, y is equal to 38.3. So when our time is equal to 12, our distance is equal to 38.3 feet. What about when our time is equal to 7.4 seconds? Now we'll go backwards. So when I make x equal to 7.4, then y is equal to 25.4. So our distance is equal to 25.4.